Hello, this is Siddiq Masood Ahmed with the Department of ECE from Padmasri Dr. Raju Institute of Technology. We are representing our college in this edition of Texas Instrument India Analog Design Contest 2012-13. We are team number 54-2. Alongside me are my 3 team members who will subsequently introduce themselves. This video is about our project, the PC-based linear IC tester. Testing is a very critical phase of any design process, and especially electronic prototyping and PCB design making requires the integrated circuits are perfectly tested before deploying them to avoid the system failure due to faulty ICs. So there were 2 strong reasons which motivated us to undertake this project. First is that there are very meager but costly solutions available for testing the analog ICs, and they are with very limited libraries. This is because of the fact that testing the linear ICs requires continuous analog signals to be applied to them, which is comparatively difficult than the digital ones, which requires discrete logic levels to be applied. The second reason is the increasing issue of IC counterfeiting happening nowadays. ICs from damaged and scrapped PCBs are directly pulled off and sold by combining them with the good ICs by remaking and repainting them. In some cases, the silicon die itself is a fake. This causes huge loss to the PCB manufacturing firms. Thus, it becomes important to thoroughly check the ICs before they are being used. So, we propose a method of testing linear ICs and attempted to build a simple prototype verifying the same. The remaining part of the video will be the explanation of our implementation and a prototype demonstration.
Hello, this is Srinivas, the student coordinator of our team for our project, the PC-based linear IC tester. In the next couple of minutes, I will attempt to brief you through the implementation and design of our proposed solution by guiding you through some slides. So let's now dive in. This is the system level block diagram of our implementation. Now we propose to test an IC by programming a basic test circuit around the IC and applying some test signal inputs and checking the corresponding output at the output pins. Thus the key focus and design issue is being able to design this programmable interconnection network. Here we introduce a concept called analog bus. The analog bus is a dynamically configurable programmable structure which can dynamically route analog signals between multiple nodes. The nodes shall be chosen by a digital controller. A PC host provides a user interface to communicate with the onboard controller. It contains the IC testing routines which are passed to the controller while testing. You can see that in our proposed design there are actually 2 sections, the analog section and the digital section. The digital section is the main controlling section which will give out control commands to the blocks of the analog section. We can also use latch shift registers if there are a less number of ports, but for our prototyping we use the TI MSP 430 FG4618 F2013 experimenter board, which has a lot of ports available with it. The analog section is the significant part. It has primarily 5 major functional blocks which are the power supply, the input block, the output block, the component bank and the IC test socket, and along with the analog bus. Each block is connected to this analog bus so that it is accessible to every other block via the IC and test block. We now go through how each block is implemented. The power supply is a straightforward one with the stages as shown here. The output of the power supply is connected to the analog bus, thus it is available to every other functional block. The input block is built using several digital to analog converters connected to the analog bus. The TACs are controlled by the microcontroller and they are buffered before using them as inputs. The output block is a combination of several analog to digital converters which collect the analog output signals from the bus and convert them to digital for the controller to study these outputs. Next, the component bank contain the several linear components like the programmable resistors, capacitors, etc. These components are connected at both ends to our analog bus. This gives the programmable connection of components to the IC. The IC socket is also connected to the analog bus, through which it receives the connections from all the functional blocks. And finally, the last one is the main concept of our analog bus. The ability of the analog bus to dynamically route the signals is due to the use of multiplexers and switches. Although it was first our idea to use switches and multiplexers to implement the analog bus, we happen to refer to the Cypress Technical Reference Manual for the Programmable System on Chip PSOC 3, which makes use of the similar concept of analog bus. And thus we derive the name of analog bus even from the same manual. The analog bus in our case has been implemented using the CD4051, the 8 channel analog multiplexer, and TS12A4514, the digitally controlled analog switch. Now, by applying proper selection logic and operating the switches, we operate the analog bus, which makes it possible for the interconnection, which is programmable, and that to happen between all the other sections of the board.
Hi, this is Venkatesh Tota. Now I am going to demonstrate our prototype. This is our basic prototype setup which we had built to test our proposal. As shown in the earlier presentations, we have divided our setup into 5 sections. The power supply, the inputs, the outputs, the component bank, and test socket with a simple analog bus. We used a direct RPS as a source of power supply. This is the DAC 8554 evaluation module featuring the DAC 8554 digital to analog converter, a 16-bit quad channel voltage output DAC with a serial input interface. This is the THS1206 evaluation module featuring the high-speed 12-bit ADC THS1206. We are using MSB 430 FG4618 F2013 experimenter board as the digital controlling section, which will communicate with the PC to obtain the testing routines from the IC under test. It is also controlling the analog section containing the analog bus and other components. This PC board features the test socket with a simple implementation of analog bus using CD4051 analog multiplexer, a single 8-channel multiplexer which is digitally controlled by internal analog switches. For the demonstration purpose, we chose to test only 8-pin dual-in package ICs. We have a working op-amp 2277 and a failed op-amp 2277, which we are going to test. For the current demonstration, we have given the feature of LED blinking with yellow LED indicating a pass and red LED indicating failure. Now we are going to place a good IC on the ZIF socket. Pressing this button starts the test. We can see the yellow LED indicating that the IC is working properly. Now let us place a faulty IC and test it. The test starts now. The red LED blinking indicates that the IC is a faulty one.